Alright, you guys, this won't take long. There's not a lot to write. We're introducing some, well, rules and vocabulary that lets us to reason through problems. We have one learning target. I can identify inductive and deductive reasoning, and there's a lot of paper here that we're not going to write on, we're just going to talk about, but stay with me through this. The first definition is what a conjecture is. Conjecture is a statement that is believed to be true. And then we can use inductive or deductive reasoning to show or prove or test our conjecture. Alright. Inductive reasoning. I'm going to circle this I. It's when you use your eyes generally, is when you observe stuff, right? It's the process for reasoning a rule or a statement to be true because specific cases, and I'm going to show you down below, appear to be true. This does not mean the conjecture made using inductive reasoning is necessarily true, but it could be. Alright. Deductive is when you have logical rules to draw conclusions. A conjecture made using deductive reasoning is true. If you know there's rules in place and your rules make this true, it's true. So let's see if inductive will just say I and deductive will say D. Alright, so which below are examples of inductive reasoning? Well, Bella notices there's a key right there. It's probably true. She's using her eyes or observations. That the last two times, Max, noticed the last two times he was late to class, he had been assigned ASD. Max makes a conjecture that he would be assigned ASD when he was late. Well, that is definitely inductive reasoning, right? Because he made observations and made a conjecture. Bella notices that she used the inner set of numbers on the protractor to measure an angle. Thus, Bella made a conjecture that one should always use the inner set of numbers when measuring an angle. That is inductive reasoning, right? But it's not true. I'm just going to put NT right here. She made an observation. She induced, right? She made inductive reasoning that it was true, but in this case it's not going to be true. Alright. This guy down here. Which ones are assigned deductive? So if there's a rule we're following, right, it's deductive. Teacher tells the class that ASD will be assigned for tardies. There's your rule. Max knows he will be assigned ASD today since he was late. Alright, so that's deductive. Definitely. There's a rule we're following. The protractor direction states that the inner set of numbers is used only when you measure an angle from the right and outer when you measure angles from the left. Okay, Bella knows she must use the outer set of numbers since the angle she is measuring opens from the left. I like it. So that is inductive. And this inductive one is true. I'm sorry, that's deductive. We used a rule that's on there, and this one is true. Alright. So identify which ones are inductive or deductive. Alright. So 2 plus 8 is 10. 4 plus 12 is 16. The sum of even numbers is an odd. We made two observations. I'm sorry. And then we say, therefore, the sum of even numbers is an odd number. You know what? That's just dumb. I'm going to change this to even, and because I'd have to say neither, and that's an inductive. You saw something. When you see something with your eyes, it's inductive. Alright? If two lines intersect, they intersect each other at one point. We've got a rule, right? J and K intersect, they intersect at one point. That's deductive. We followed a rule. Alright. Now a counterexample, right, is if you're trying to prove something wrong, you think of something that doesn't fit that. A counterexample is an example that shows your conjecture to be false. Alright, so if we can think of one for these, we've got a counterexample. That's how you misprove or disprove, a conjecture. The product of two integers is always greater than both original integers. Well, let's see. What if I add 1 plus negative 2? That's negative 1. Negative 1 is not greater than 1, so not true. I thought of an example that made this rule not true. This is the counterexample right here. For any real number of x, any number of x squared is greater than 0. Well, for most numbers it is, but when I use a fraction, which is still a real number, 1/2 squared is 1/4, and 1/4 is not greater than 0. So there's our counterexample, and we proved it's not true. I'm going to stop here. There's the first page, and we'll keep going later.